Okay, guys, so what we're doing is we are going to start, we're going to move into chapter 9 and 10. We're starting with chapter 9, and chapter 9 is all about probability. So if you don't know what probability is, it's much of it, not all of it, but much of it is playing games. It's basically what it is. And basically, what are your chances of winning? You can think of it that way. It kind of usually helps people get into it a little bit more. All right, so what our focus is today is on, we're going to talk about a lot of different probability and different types of things that happen, different kind of games basically. But today what we're starting with is we're just starting with the probability of simple events. So we have a lot of vocab here. So here's our very first word, and that is probability. Everyone? Probability. So your book says probability is the chance that some event will happen. Okay, event, we'll get into that, but that's basically something, happening while you're playing a game, what you're trying to do, what you're trying to win, or your goal, basically, on how to win. So it goes on, it says, it is a ratio of the number of favorable outcomes to the number of possible outcomes. All right, we'll be writing this in a little while when we start our homework. It's the ratio of the number of favorable outcomes to the number of possible outcomes. In your little box, go ahead and write this down. You don't have to write those last parentheses. Those are just showing you that's in the box. But P, and then parentheses with a 1 in it, equals 1/6. What that's saying is, it's kind of abbreviations to say the probability of getting a 1 is 1/6. A 1 in 6 chance. So, for example, I don't know if that's exactly what it means. This is exactly what it means, but I'm thinking of like rolling a number cube, right? Dice or a die, a singular, okay, number cube. We've just talked about this in geometry, right? How many sides are on a number cube, guys? 6, right? Rectangular prism, a cube. 6. A 1, though, rolling a 1 on that number cube, if you're just going to roll that number cube, rolling a 1, you have a 1 in 6 chance of rolling a 1. All right? That's what that means. We'll get into more detail about that here in a bit. All right? Our next word is the word outcome. Everyone? All right, so it talks about favorable outcomes, possible outcomes. Well, here's what they mean by outcome. Any one of the possible results of an action. For example, 4 is an outcome when a number cube is rolled. Right? It's one of the things that can happen. You could roll a 4. That would be considered one possible outcome. All right? We're not going to write anything in the box because that second sentence in their definition is a pretty good example. Okay, our next word, talked about probability, but this is the second part, a simple event. Everyone? Simple event. So, this is just defined as one outcome or even a collection of outcomes. So you'll see what it means by a collection when we're doing our examples. Okay? So not rolling dice isn't the only kind of little event that, or a game we can play. I mean, you have a little spinner, right? Just like on the worksheet we were just fixing. Spinning a 6 on a spinner. All right, that would be an event that could take place. Okay, now this is pretty important. Random, everyone? Random. Okay, so first of all, the definition of random is outcomes occur at random if each outcome occurs by chance. For example, rolling a number 1 on a number cube occurs at random. In a little box there, just put anything can happen. It's a condition where anything can happen. All right. Thanks. That's our solution. Okay. Now, going back to random, right? This is a very important word because for probability, what we're talking about, like playing a game, for probability to be true, things you have to do something that the outcome could be random. It has to be random, right? If you play a game, all right, and you're spinning a spinner, and you flick the spinner, right? But you flick it, you barely touch it because you really want let's say you want to spin a 5 because you know if your little man on your board game or whatever moves 5 spots, you win, right? And the next one up is 5 and you barely touch it and that little needle goes, and it goes to the 5. You go, I win. Okay, that most of us consider that cheating, right? You're cheating. Why? Because it's not random. A spinner, you want to flick that thing hard enough where it spins 10 times. After that, you don't know where it's going to end up, right? That is what makes it random. Those of you that are sports fans, you talk about sporting events, right? Sometimes, in some sports anyway, not all, but in some sports, at the beginning to see who gets the ball first, what do they usually do? Flip a coin, right? You have heads and you have tails. So do they flip it strategically where it just kind of hovers up and it lands and they're like, haha, it's heads? No, they flip it where that thing just turns and turns and turns and turns, right? They used to catch it in the NFL nowadays. They let it hit the grass and they read the coin off the grass. But they think that, of course, it becomes more random if you let it do something like that. So the fact that it's turning over and over and over again, it becomes, the more it turns, the less likely it is for it to be any kind of strategy to it. It's going to be random. It's going to land on the ground, and it's going to be, basically gives an equal chance to both teams, right? So that's what it means by random, okay? So any little game you play, you have, rolling dice, right? You roll dice, you roll it in a game, well, you roll that dice and you make sure that thing tumbles quite a lot because that's what makes it random, right? You don't take it and just kind of scoot it along to get a 4. Make sure the 4 is up and you scoot it along the table and go, haha, there's my 4, I win, right? That would be cheating, all right? So random is a major factor when you're talking about probability, okay? So our last one is will pop up on your worksheet. It is something that you guys need to know, and this is complementary events. Everyone? So, your definition says, in the book says, the events of one outcome happening and that outcome not happening. They're complementary events. So, for example, it says the sum of the probabilities of an event and its complement is 1. They give you an example right here in the definition. It shows the probability of maybe spinning an A plus the probability of spinning something that's not an A is equal to 1. Now, it might get confusing, but you see that right there? That number 1, you're like, what do you mean by 1? Well, that's actually decimal form. 1 decimal point 0 or 0, 0. If I change that to a percentage, what do I do with the decimal? Move it twice. What percentage do we have? Yeah, so that's what it's talking about. Complementary events, spinning an A or spinning not an A equals 100%. All right, it's going to happen 100% of the time. Let me spin this. I'm either going to get an A or I'm going to get something that's not an A. Well, what else is there, right? It's everything. It's 100%. So that's what that means by a 1. So in your little box, this is another little example. Rolling a 1 or rolling not a 1, right, on a number cube, which on a number cube, that could be 2, 3, 4, 5, or 6. Well, doing one of those, it's 100% of the time it's going to happen. You're going to roll a 1 or you're going to roll a 2, 3, 4, 5, or 6. Congratulations. You're guaranteed to win. But those are considered complementary events. Not the chance so much, but the event itself. Rolling a 1 or rolling something that's not a 1. All right, guys, questions on any of those? Okay, let's go ahead. Let's take a look at some examples, okay? Go ahead and grab your worksheets. And let's start on the 9.1 skills practice side. All right, so when it comes to probability, especially this chapter, you're going to want to read the directions pretty carefully because little things may change, and it will change maybe the outcome of what your answer is. But also, half of the time, it not only gives you directions, but it actually tells the story of what the game's all about. It describes the possible game. So let's take a look. First of all, I'm going to let you copy it down. All I'd like you to do is just, which most of you guys love doing, just put your pencil down. All right, I just want you to watch this first one. I'm just going to show you how easy these problems are today. All right, so it says probability of simple event. So it says, in the directions, it says the card's randomly chosen. Okay, and there's that word, right? Meaning that they're probably not facing up. They're probably facing downwards and they're shuffled, and you don't know which card is where. All right, that's what it means by randomly chosen. It says find each probability. But look at it. It says write the answer as a fraction, a decimal, and a percent. So here's what I'm going to do. I'm just going to do problem number 1. So here's what this means. They want to know what is the probability of choosing a B in this deck of cards. Okay, so before we do this, I want to remind you guys of what it showed in our notes, all right, in our vocab notes. It says remember simple events or probability of simple events is the ratio of the number of favorable outcomes over the number of possible outcomes. Okay? So we can say, well, what does that mean? Well, that's why I'm doing this, to show you guys. The number of possible outcomes is basically how many of these cards are there? Well, there's 1, 2, 3, 4, 5, 6, 7, 8. The number of possible outcomes, I have 8 different cards I can choose. That's our denominator. Okay? The number of favorable, this is your favorable outcome. That's the event that you want to occur. Basically, kind of think about it as like winning the game. So, probability of choosing a B, I count how many B's there are on here. There's only 1. Now, I would reduce that if I can, but I can't. All right? So that's my fraction answer. However, it does say, right, change the fraction to a decimal and the decimal to a percent. So calculators, a lot of these, some of them could be mental math. A lot of them, though, you can use a calculator. 1 divided by 8 equals 0.125. There's our decimal. And then our final answer, right, is move the decimal over 2 times to the right. So 12.5%. And there are 3 answers. To win this game, you have a 12.5% chance, okay, or a 1 in 8 chance. Now, what we're doing here is we're doing something called theoretical probability, and we'll talk more about that in a bit. But what that is by counting the numbers and coming up with more than likely what your probability is for choosing that. Meaning that a 1 in 8 chance means that there's a good chance you're going to choose a B 1 time out of playing the game 8 times. You're going to win 1 out of 8 times. Okay? That's not truly exact. And actually our next lesson we'll talk more about that. But in theory, based off of numbers, theoretical probability says that that's our probability of winning this game. Okay? So guys, that's kind of the main part of what we're doing today. All right, so we're going to do one together, but what I'm going to do is just give you guys about 15 seconds. Go ahead and just write those down there. As a matter of fact, up at the top of your paper, please write that down as well. Okay. Here we go. Let's take a look at problem number 3. So, in this particular problem, problem number 3, talking about simple events, step 1 is create your ratio, and let's write down our possible outcomes, meaning just count how many there are. Well, in this case, right, it's the same game. We know that there are 8 cards there that we can choose from. 8 different outcomes, or 8 different cards in this case. Step 2 is take a look at what it says the favorable event is, favorable outcome. All right, and that favorable outcome is choosing a vowel. What's a vowel, guys? A, E, I, O, U. Sometimes Y, but we don't have to worry about that right now because there's no Y here. So here we go. What I'm going to do is I'm going to go up over here and I'm going to count how many vowels there are. Is K a vowel? O? Yes, there's 1. R? E? There's 2. Q? A? 3. Is B? S? There are a total of 3 vowels. We can win 3 out of 8 ways. Now, I'm going to put a little step star here, and that means sometimes, guys, don't forget to reduce if you can. Reduce the ratio. Okay, it's in fraction form, reduce it. That 3/8 can't be reduced. Okay, which leads me to step 3, and that is, let's go ahead and change this to a decimal. So you could divide 8 into 3 if you want, longhand, but I'm going to go ahead and punch in 3 divided by 8 in the calculator, and that gives me 0.375, 375 thousandths. And then step 4, once you get the decimal, move that decimal over 2 times to the right, and we end up with the percent, 37.5%. And there is our answer. All right, guys, questions on that one? I'm going to have you guys try one just like that. Okay, here's what I'd like you to do. Go ahead and flip the page over. Okay, what I want you to do is that spinner we altered, okay, you're going to do that part. Make sure you read the directions carefully, and I want you to do problem number 7. Problem number 7, all right? I'll check in with you in about 1 minute. Go. Okay. You don't need more time? Bless you. Okay, 30 seconds. Go ahead and turn to your neighbor and share your probabilities. Go. All right, here we go. So in this game it says, use the spinner at the right to find each probability. Write each answer as a fraction, percent, and decimal. All right, so remember our ratio. I'm going to write the start of this ratio. And remember, I'm going to go ahead and start by writing the number of possible outcomes. In this case, well, it's numbered 1 through 8. That tells me there are 8 possible outcomes on this spinner. Okay. Now, the second thing, right, is what's a favorable outcome? Well, it's spinning an even number. So kind of like the vowel problem, right? I have to do a little extra thing, not much, but count my even numbers. Well, 2, 4, 6, 8 are even numbers, and that's 1, 2, 3, 4 of them. So there are 4 even numbers. Now remember, step star was reduce if you can. So they're both even numbers, but beyond that, we can reduce both by 4 and get the ratio of a 1 to 2 ratio, 1 out of 2. Now, you feel free to punch in the calculator, but I'm hoping that you guys know that decimal-wise, that's 0.5. You move that decimal over twice to the right, and we end up with 50%. So you have a 50% chance of winning this game, which is better than picking a B in those cards in that last game, right? This game's a little easier to win. All right, questions on number 7?
Would you get it wrong if you didn't reduce?
You should reduce, yes.
Like, but when you get it wrong?
Is it in our steps? Okay, so you should reduce. Bless you. Guys, other questions? Okay. Let's go ahead. Let's take a look at same side. Let's check out problem number 3. Problem number 3. Okay, let's go ahead. We have this little story up here. Let's go ahead and close read the story. Here we go. A set of 30 tickets are placed in a bag. There are 6 baseball tickets, 4 hockey tickets, 4 basketball tickets, 2 football tickets, 3 symphony tickets, 2 opera tickets, 4 ballet tickets, and 5 theater tickets. 1 ticket is selected without looking. Find each probability. Write each answer as a fraction, percent, and a decimal. So the fact that they're placed in the bag, you are sticking your hand in there without looking. That's what makes it random. All right, so we take a look at problem number 3. They want to know what's the probability of choosing an opera or a ballet ticket, meaning that you're going to win with either one of those. All right, so the very first thing I'm going to do, right, is write my ratio. I'm going to go ahead, put my bottom number, the number of possible outcomes. Well, I can count all these tickets if I want, but it saves me some time. This particular one tells me there's 30 of them in that bag. So that's the total number of tickets. That's what my bottom number is, the number of possible outcomes. Now, favorable outcomes, remember we win if there's opera or ballet. So if I take a look at this. Here's opera. There's 2 of them. And here's ballet. There's 4 of them. So how many different ways can we win, guys? 6 ways, right? So 6 out of 30. And that, of course, is nice because we can reduce both by 6. So 6 divided by 6 is 1. 30 divided by 6 is 5. We have a 1 in 5 chance. So with that, okay, some of us can do it in our heads, right? So if you can't, 1 divided by 5 gives me the decimal 0.2, 2/10. And moving that over 2 times to the right, that is 20%. Okay, questions? All right, I'm going to have you try one kind of like that. So I want you'll have to read the story, go down on that same side, go down to problem number 17. Try 17. All right, 17, go. Anyone need more time? Okay. Those of you that are finished, you can go ahead and continue on that side of the worksheet there. Okay, anyone still working on it? Okay, 30 seconds. Turn to your neighbor and share. Go. Okay, here we go. On the bottom here it says a package of balloons contains 5 green, 3 yellow, 4 red, and 8 pink. Suppose you reach in the package and choose one balloon at random. Find the probability of each event. Write the answer as a fraction, percent, and a decimal. So, if I take a look here, this is a little more challenging. It's very similar to the tickets, right? But it's a little more challenging because they don't just flat out tell you the total number of possible events. So this first step here is to be able to find that I need to add up these numbers here. So 5 and 3 is 8, 8 plus 4 is 12, and 12 plus 8 is 20. So the total number that goes on the bottom is 20 possible outcomes. Now, remember favorable outcomes is shown right here, red or yellow. So if I take a look, here's the red, there's 4 of them, and there are 3 yellow. So 4 plus 3 is 7, so we win 7 out of 20 ways. So 7 is prime, meaning it can only be reduced by itself and 1, and 20 can't be reduced by 7, so that we cannot reduce. So I go ahead, change this to a decimal. 7 divided by 20 equals 0.35, and if I convert that to a percent over 2 times, we get 35%. All right, questions on that? So remember on our definition where it says a simple event is one outcome or a collection of outcomes. You might go, well, why is that a simple event, singular, but it's a collection of outcomes? Well, this is what it's talking about. Okay, so more than one favorable outcome. Okay, here we go. Let's go ahead and next one, let's check out problem, very similar, but let's take a look at problem number 5 on the same page. Okay, going back up to the tickets in the bag. So here we go. We have something a little different. The very first thing is the number of possible outcomes on the bottom. Well, we know there are 30 tickets, so that's easy. Favorable outcomes are on top. If you take a look, right, I have not once, other than the very first time, I haven't written different steps because the steps are exactly the same. It's just these little twists that I want to point out to you guys. So 30 tickets. We're a winner, or a favorable outcome, I should say, is anything that's not symphony tickets. Anything, if you get symphony, it's not a good outcome, not favorable. But if it is anything other than symphony, we win. So if we take a look, there are a total of 30 tickets. Should I add up 4 plus 4 plus 2 plus 3 plus... No, what should we do? Yeah, subtract the 3 symphony tickets. So you have a total of 30 tickets. you subtract the 3, because those are basically the losing tickets, and we get a total of 27 favorable outcomes. I can reduce this, simplify, by 3. 27 divided by 3 is 9. 30 divided by 3 is 10. So we have 9 and a 10 chance there. And that's 9/10 as a decimal. Of course, I could just rewrite 9/10. That's how you write 9/10 as a decimal. And move that decimal over 2 times, and we get 90% chance. All right, that's a good game to play right there. All right, so I'm going to give you one similar to that. Any questions? All right, go ahead and try out problem 18 down at the bottom. Problem 18. Anyone still working on it? Okay, a few more seconds. All right, 30 seconds. Turn to your neighbor and share. Go. All right, here we go. So what's the probability of choosing something that are not green balloons? Well, the nice part is we already found out, we don't have to count over how many possible outcomes there are. There's 20. Okay, so remember, favorable outcomes goes on top. So anything that's not green balloons. Well, because there's a total of 20, and when it comes to green balloons, there's 5. So we just say, well, 20 minus 5 is a total of 15, because all the others are favorable outcomes, so a total of 15 favorable outcomes. If I reduce by 5, 15 divided by 5 is 3, 20 divided by 5 is 4. I have a 3 in 4 chance. So most of you guys know it's like having 3/4 of a dollar, or 75 cents, 0.75. And move that to the right twice, we end up with 75%. All right, questions? Okay. All right, so here's what I want you guys to do really quickly. Is in life, when we just casually talk with people about the chances of something happening, we usually don't say, unless you watch the news and you watch weather, right? But most of the time we don't say, There's a 35.6% chance of that happening. Okay, we don't say that, right? You use actual casual words. Well, what they've done is your book has taken the numerical value of something, the chance of something happening, and they've given words for you to use. And that's actually this next part. So what I'd like you to do is take your book, all right? Some of you guys have your book out. Others of you, go ahead and grab your book. Flip over to page 712. 712. So here's what I want to point out. On page 712, you see this like colored spectrum, and they just kind of color coded it. The colors really don't matter. So here's what they say. Let's start with the obvious, okay? If there is 0% chance of something happening, no chance at all, in life, we say if there's no chance it's going to happen, it's impossible. It's an impossible event, right? It's not going to happen. It's impossible. On the other hand, if we take a look, right, if it is surely going to happen, 100% chance it's going to happen, they say that's a certain event. That is certainly going to happen. It's going to happen. It's certain. Okay? Now, of course, the closer you get to certain, but it's not quite 100%, a little less. Okay? They use the number 75%, but it doesn't have to be. It can be 99%. 99% is not certain. It's probably going to happen, but it's not certain, right? But they consider that a likely event. It's likely going to happen. Okay, on the other hand, right, 25%, 13%, 5%, something low like that, it's unlikely going to happen. More than likely, right, it's not going to happen. They say it's unlikely. And they have this little phrase here, as likely to happen as not. Okay, so it gives you guys some terms to use when you solve these next problems. Okay. So just a little book page to refer to as a little resource. But here's what I want you guys to do. Let's go ahead and let's stick to our worksheet there. But let's flip back over to where we started, which was the skills practice side. And let's take a look at problem number 9. Okay, on problem number 9, I'm going to go ahead and read the directions. It says, the spinner shown is spun once. Write a sentence explaining how likely it is for each event to occur. So here's what we're going to do. Step 1 is before you even talk about the likelihood of an event, let's find the probability. So I'm going to write my ratio, possible outcomes. There's 1, 2, 3, 4, 5, 6 equal sections on this spinner. By the way, equal sections are very important on a spinner, right? Just a little side note. If that was our spinner, you don't say, oh, you know what? To spin a dog, to get a dog, I have a 1 in 2 chance. But Mr. Wilkins, there's 2, a dog and a cat, and there's only 1 dog. So probably, right, that doesn't work that way, right? Because they have to be an even size to make that true. All right, this is more, if you think about it, this, I mean, you could put this, and this isn't even accurate, right? But that's more like a 1 in 6 chance, not a 1 in 2 chance, okay? All right, so here's what I want to go back to. I just wanted to talk about that because that may pop up coming up on a test, especially state testing. They may try to trick you with something like that. But if we take a look at this, what's the probability of spinning? What's the probability of spinning a dog or a cat? So take a look. Dog, dog, cat, cat, dog. There are 5 favorable outcomes. It's a 5 in 6 chance. So 5 in 6 chance. If I wanted to, I could convert it to a repeating decimal. Sorry, that's not the repeating decimal. I was getting ahead of myself. I was writing the percentage, because when I move it over 2 times to the right, I get my decimal. So if I take a look, right, 83% is a little more than 75%. We're looking at a likely event. So when it says write a sentence explaining how likely it is for each event to occur, that would be step 2 is the event is likely to occur. So I'll put a little star by step 2 just because make sure you use the words that are on that spectrum on that page. Use it as a resource. Okay, questions on number 9? All right, one last type of problem on this worksheet. Try out problem 10. Problem 10, go. All right, anyone need more time for number 10? Okay, 30 seconds. Turn to your neighbor and share. Go. All right, guys, number 10, here we go. What's the probability of choosing a bird? Well, possible outcomes. There are 6 possible outcomes. How many sections have a bird? 0 of them. 0 have a bird. So that is, obviously, as a decimal and a percent. Ladies and gentlemen, if I'm taking a look at this, 0% chance is right there. It says the event is impossible. Not going to happen. You can't spin a bird when that's not even on the spinner. Okay? All right, guys. So, a lot of little problems, but not too hard of problems. All right? So, probability of simple events.